Hi there. It's important to distinguish between control limits and specification limits. They serve very different purposes. Specification limits, also known as tolerance limits, are design specifications that are set by the product designer. They are based on product characteristics that are important to customers or the characteristics of parts that will be assembled together. If an item's characteristics do not fall within the specification limits, the parts will not fit together appropriately, or the item will not meet customer expectations. In contrast, control limits only reflect the historical operation of a process. They do not reflect whether or not a part's characteristics fall within the specification limits. Control limits are calculated, not set, because they are based on actual process operation. If an operator finds that a sample characteristic, mean or range, does not fall within the control limits, he or she should immediately stop the process, determine the reason, and perhaps take remedial action to bring the process back in control. Control limits do not tell us whether a process is good or bad, only whether it continues to operate as it was in the past. Now, both control limits and specification limits are important, but for different reasons. By monitoring process characteristics using control limits, we can determine whether a process is changing, for the better or for the worse, over time. There are two ways that a process can change over time. First, its central tendency can change. This is reflected when the sample mean increases or decreases. It can increase or decrease gradually, which typically indicates fatigue on the part of the operators or wear and tear on a tool or machine. There can also be an abrupt and sustained increase or decrease in the sample mean, which is typical of a shift change or new employee or changing raw materials. The second process change that can occur is a change in the variability of the process, in the spread of the process. This is reflected when the sample range or standard deviation increases or decreases. Similar to changes in the central tendency of a process, a gradual increase or decrease in process variability often indicates fatigue or wear and tear, while an abrupt and sustained change often indicates the effect of a shift change, a new employee, or changing raw materials. Process capability describes a situation where the process control limits fall within the specification limits, and therefore the process is capable of producing to specs if it operates as expected. On the other hand, if the process control limits fall outside of the specification limits, the process is expected to produce some items that don't meet specifications. You can start examining each plot to determine whether the process mean is centered within the specification limits. To calculate the process capability index, you should use CP when the process mean is centered between the specification limits. How do we compute CP? It's very simple. You take the upper specification limit, subtract from the lower specification limit, and divide by 6 times the process standard deviation. So upper specification limit minus lower specification limit divided by 6 times the process standard deviation. Now, you should use CPK when the process mean is not centered between the specification limits. Here is an example of this later situation. So how do we compute the CPK? Is the minimum between the upper specification limit minus the process mean divided by 3 times the process standard deviation, and the process mean minus the lower specification limit divided by 3 times the process standard deviation. So CPK is going to be whichever is lower. If the process capability index is greater than 1.33, the process is capable of meeting specifications.